Well, welcome everyone. Can everyone at the top hear me okay? As the lights turned off, so I have no idea if you put your hands up or said yeah. All right, so this is going to be a session. It's got the word microservices in the title, so everyone turns up. But it's going to be primarily about the problems I faced when I broke a large monolithic system up into many components. And you get exposed a lot to the network, and people then get scared and they pretend problems don't exist when they really do. So a little background, so you know why I'm talking about this stuff. So I work for a company called DataStax now, which actually are the people behind Apache Cassandra, when in reality, virtually everything I'm going to talk about over the next hour are from this company, which is a very large television provider over in the UK. And we were building their new generation television platform. We were replacing an existing monolith, and we were breaking it up into small components. That probably sounds familiar. Lots of conference talks about that. How I'm hoping that this is actually going to be different from the other talks that you've been to is I'm going to wave my hands in the air for a few minutes and say, yeah, separated components are great. You can deploy them. Wow, that's exciting. But then we're going to spend nearly all of the time talking about the problems you face because you've decided to do that. Because distributed systems are hard, and we often are abstracted as developers from the network, whereas if you decide to go down this whole microservices bandwagon, you're going to learn a lot about TCP. You're going to learn a lot about failures. You're going to learn a lot about how to do deterministic timeouts and things like that. I apologize if you're in my other talk on Apache Cassandra, because the next 3 slides are the same. But then we're going to deviate greatly. So when we were basically replacing a system which had been around for a long time, it had been built for around 5,000 to 10,000 users, and it was built like many of our Java applications are. It was a good old Tomcat container. If you're not aware, this is the Tomcat logo, and it spoke to an Oracle database. It was very much designed to run on a single server. We were only expecting the 5,000 to 10,000 users. But it turned out that a lot of people liked watching Game of Thrones on the toilet or whatever, and people do like streaming television. We don't like to be told these days when to watch something, we just want to click a button. So internet television did take off. We had to then scale this system, and I say we, this was before I joined the company. So it was scaled to many nodes with a very expensive F5 load balancer in front. By the time that we started replacing it, there was around 60 instances of it. The database was feeling the strain, and the problem is it was designed very much to run as a single server. There are lots of design decisions you need to make when you want to be able to horizontally scale services, which, if you don't take them into account, you're going to feel pain when you do things like this. What typically happened was, of course, we deployed more of these as more users came in, and then eventually the data store decided to fall over in a heap. That wasn't always it, though. What eventually would happen was a few of the Tomcats would fall over. Now, this could be because of excess load. It could be because we're doing a release. It's just when you've got many services, many computers, you're going to have to restart them and patch them, etc. And we were using this dreaded thing called session state. Now, session state in containers is wonderfully easy to use. It's amazing. You get a user in, you log them in, you authenticate them, you stick something in the magic session, they come back in, it's still there. This is not something that scales really well. Why? Because when we restart a server, when a server falls over, at this point we probably had 10, 20, 30,000 users on each server. So when a few fell over, everyone would get logged out, everyone would log back in, and then we'd end up with a big pile of mess. So, we'd basically be, our servers are going down, we overload the existing ones, they go down. So what was the solution? Well, we didn't know the term microservices at the time, and I probably wouldn't describe what we did as microservices because we certainly let them get a bit bigger. But we thought what we want are separate components that we can scale independently. That's what everyone says is the big benefit. We want to be able to deploy them independently. We want, code bases which can new developers can work on and, learn the code base within, a few days and be productive. All of that sounds great. However, there are a lot of problems to it. Now, we couldn't migrate right away to a new magic system. We weren't doing a big bang. So what we did is we migrated a few services across. A couple of services in particular. We had one which was keeping track of everything our customers ever did for the whole of time. We used this for billing, we used it for analytics, and it stored all of this previously in this guy, the database on the right. However, we made the existing service call out to a new service and stick it in a Cassandra cluster so we could keep this guy alive for longer. We did that for 1 or 2 services, but then eventually we threw away the whole thing. And we haven't quite got there yet. I still go into this company to consult because they're now our customer. So the end goal was something like this. Lots of separate services, loosely coupled, each with their own kind of database, which in fact was a Cassandra cluster. Some of them didn't have databases, some of them did. Now, I'm not going to describe the entire system. It was in the order of 10 to 20 services. In this talk, I'm going to do something vastly more simple, which is just extract a few that we're going to talk about. And we're going to talk about the problems faced when developing a service which calls out to other services over HTTP and maybe a database. Now, when I first learned about all of this and learned vastly more about TCP, because for some reason we thought it was a great idea to separate our components on different servers, I decided, hey, I want to talk about this. So I extracted this really simple example. I whacked it on GitHub, as that's where everything goes now. It's like dev null. And then, so I could actually show you some code from some of these, for some of the techniques. Now, we were big fans of dropwizard. I actually have a new definition for a microservice. If you need to use a dependency injection framework, it's not a microservice. Okay? So that's why we used a lot of dropwizard, but we did use some Spring Boot as well. Back then, Spring Boot was just starting, and it was just coming about, and it was very much a bad copy of dropwizard. Now it's pretty awesome. We used a lot of Wiremock. So if you haven't come across Wiremock, what it is, it's a test double for HTTP. It'll open a port, and you can tell it to do things. You can tell it to do things like respond with this nice response, user data. Or you can tell it to do nasty things. You can tell it to add delays. You can tell it to send back, invalid HTTP. So you can start to test when your dependencies are misbehaving. Hystrix, there's already a really good talk yesterday I attended on Hystrix, which was absolutely fantastic in describing the whole API of Hystrix and why you might want to use it. We'll be doing a few solutions with Hystrix. The kind of pattern I'm going to go through is big problem, weep for a while, then how we fix it, and also how we recreate it in test environments. I'm a big believer in basically telling people to be quiet or shut up if they say you can't recreate something in a development or test environment. Who here is probably, you've heard it, a service hung in production, and someone said, yeah, it's a network glitch. We're not going to actually investigate that. It only happens every few days. We won't bother with that. Where in reality, it's really quite fun. It's really fun as developers to try and understand what's going on under the covers or in the wires and trying to recreate it deterministically so we can create tests for it. A couple of other really cool things. Graphite, I have a love-hate relationship with Graphite. It's a really good metric server, but then it becomes your scaling bottleneck because you've got 100 services all sending metrics to one little guy. And Saboteur. Now, Saboteur, if you haven't come across it, is a really cool tool. What it does is it essentially allows you to inject network faults. There's nothing fancy. The source code for it is really quite small. It's using a set of commands on Linux called IP tables and TC, which is the traffic shaping command. And you can get it to do some funky things and then recreate these bugs, these problems, these issues that happen in production. The common theme that I'm going to harp on about is if you don't test something, then you've got no idea that it actually works. It might work today when you tried it. It might not work in the future. I read, I don't think I came up with this, that if you don't have an automated test for something, it is not a feature, it's just a rumor. It might be there for a while, and eventually it's going to vanish. It might be true, it might be not. So I'm not going to come up with any problems, I'm not going to then tell you how you could create a deterministic test which is going to run really quickly. And I'm going to use this term a lot, the test double. Now, test doubles are really important. I'm not talking about doing anything in the process, not talking about JMock or Mockito or any kind of like mocking or stubbing inside your JVM. I like to do test double at the protocol level. So I want something that's going to basically pretend to be my dependencies, and as far as my application is concerned, it's real. It's the real network, I'm using the real driver. I really don't like it when people say, oh, I don't need to test my HTTP client because someone else wrote it. And you'll find that if there's a bug in the HTTP client, no one cares that it isn't actually your code, right? You're building a war or an executable jar or something from some other language, and you're deploying it to production. If that entity, that thing you're deploying, has a bug, it's your bug. So I want to make sure all of the drivers and libraries I bring into my project and into my process, I want to make sure they work. And test doubles are a really good way to do that. Wiremock is my favorite for HTTP, which I've started to help contribute to now because I felt guilty because I used it so much. Stubbed Cassandra is the equivalent for Cassandra. It can pretend to be a Cassandra cluster, and you can tell it to inject faults. You can say, just don't bother responding to that query, or delay it for 10 milliseconds, or pretend that you can't connect to another data center if your database is deployed across multiple data centers. And I've just started playing around with Kafka, so I've just started trying to create a test double for Kafka, though that one is pretty new. This book was mentioned in at least one other talk, and it is very much the book which is why I'm here today. So I read this book. It's about essentially it's going to be a story of a airline reservation system and a huge outage. And it talks about the techniques, all these things you've probably heard of when you hear a microservices talk, like circuit breakers, etc. You know, most of those patterns were described in this book. If you look at Hystrix, then a lot of the patterns in Hystrix are very much from this book. So I suggest you go and read it. And no one was building microservices when this book was around, or they weren't. Most of the issues, it was a monolith talking to a monolith by most people's definition. And you still face the same problems. The reason that you're going to come across it vastly more if you decide to break your software into lots of small components is you have this exponential growth of hops over the network. So if there's any problems there, you're going to see them a lot quicker, and they're going to happen more often. So we're vastly more motivated as software engineers to go and fix them. This is the type of test that I want to build for each of these bad things. So this is the movie service that we're going to talk about today. It's obviously going to call out to multiple HTTP services. This guy in the middle here is going to be built and deployed exactly like it is in production. So I'm just going to reiterate here, no kind of in-process mocking stubbing. We want this guy to think he is in production, which means that all of our mocking, our stubbing, our trying to inject faults, it's going to be the real protocol. If it's talking to Cassandra, it's going to be the Cassandra protocol over TCP. If it's talking to a HTTP service, it's going to be, it's going to be real HTTP over TCP. And I don't say you should do unit tests, of course. This is just the next step. And if you've come across things like the Chaos Monkey, etc., from Netflix, my idea of these types of tests where I'm injecting faults is not to replace that type of thing. And if you haven't heard of it, they essentially just go and kill things in production and see what happens. It's making sure that when things die in production, be it real failures or you're running a monkey that's pulling out cables, that your software handles it, that it fails gracefully. All right? So these are the 6 things, the 6 points, which I think you're gonna run into this wall when you decide to separate your component into many small services. The first one is by far the biggest, and I think the most misunderstood in our industry, and it's how to do correct timeouts. Some of the other ones are much shorter, and I just tried to come up with funny names like "Don't whack a dead horse." Why would you whack a dead horse? I'm not sure. So implementing timeouts, SLAs. Do most people then, when they build a service, they want to try and make it respond within a certain time or fail? If you don't, it's probably a good idea. Even if your business doesn't come to you and say you need to respond within 500 milliseconds for 99.99% of requests, you need in your team, in your technical team, to come up with them, because everyone knows no one wants to wait around for something to hang, it would rather fail. And this is even more important if you're horizontally scaling these small services. Because just because one of them decides to respond slow because it's having an issue doesn't mean that when the load balancer reroutes the request to another instance, that one is not going to respond quickly. So you really need to make sure that your software times out when you think it does. And if you're inside a single process, it's kind of easy. If you forget about garbage collection and other processes running on the operating system, you should be able to do it. But as soon as you start making multiple calls to a bunch of HTTP services and maybe a couple of databases, then it starts to become quite hard. So if we're developing our movie service and we're calling out to 3 other HTTP services, how do we make it time out? And you're probably going to start looking at your HTTP client. It could be the Apache one, or it could be, say, Jersey. And you're going to find timeouts. You're like, yeah, I'm going to use these timeouts. Socket read timeout, socket connection timeout. So obviously, the first one is the amount of time it takes to establish the TCP connection, right? Then you send some data, and you wait for a response. And the second timeout is how long you wait to read data from a socket. Sounds sensible. So we set these timeouts. Let's say we wanted an SLA of 100 milliseconds, and let's just pretend that we're just calling out to one service, say the user service. And yeah, it works for a while. And then eventually what you get in production is, your service decides to hang for much longer. You end up with really sad customers. And more importantly, from your perspective, is someone eventually comes and shouts at you and says, you promised to me that I was going to fail within 200 milliseconds or not, and it didn't. So you have to do some investigation. What could it be? Well, the next thing you're probably going to find in your database drivers and your HTTP clients is this thing called a resource pool. Right? Unless you're using a very rudimentary driver or client, it's not going to make a connection every single time you ask it to query something. It's going to keep a pool of connections, maybe 5, maybe 10. And what happens if they're all in use? Well, that depends on your driver. So it could keep you around, it could block you, it could reject you, it could put you in a queue. And when you think about it, if you're in this queue or you're being blocked, you've never actually made it to the network layer. So network level timeouts like socket read timeout and connection timeout, they haven't even started yet. You could spend 10 days waiting for a resource, a connection, a TCP connection, before these guys even kick in. So let's say this happens, you decide to incorporate the resource acquisition timeout into your calculating your SLA. And it works, and you're the hero. Everyone's like, yes, Chris solved the problem. Hasn't happened for ages. But it's still going to happen. You're still going to have a sad panda, and someone is probably going to shout at you. The difference now is you're the expert. You fixed it the first time, so they're going to make you come and fix it the second time. So what could be going on? Well, I like to draw diagrams when I have no idea what's going on. And when this type of thing first happened to me a number of years ago, I had no idea what was going on. So I started drawing a good old diagram. So we have some calling code, and we've got a resource pool, say, inside our HTTP client, and we're then using it to make a call to a third party, say, our user service. So yeah, we set a timeout. Perhaps our HTTP library of choice has a timeout for waiting for a connection. Yep, it's 100 milliseconds. We then make sure we set the TCP connection timeout. We'll go for 100 milliseconds again, and then we'll send the request. And we obviously then set the socket read timeout to make sure that we don't wait too long for the response. And surely this could never take longer than 700 milliseconds. Or perhaps 700 milliseconds plus a nice garbage collection plus a nice other process on your computer using up some of your time. But it's surely never going to be much more than 700. Well, socket read timeout's an interesting one, because all it really means is how long I'm waiting to read data from a socket. The clue is in the name. It has no idea what your payload is. Could be we like big XML, now we like big JSON. We like big payloads, don't we? Lots of JSON, lots of characters. And this doesn't necessarily come to us in one chunk. And if you've got a saturated network, or your dependency has been very slow and writing it to the network very slowly, then this type of thing can happen. So you might receive some of the response in 400 milliseconds. We haven't hit the 500 milliseconds, so we plod on. That timeout is then reset for the next read on the socket. This could be 300 milliseconds. And if you've got a large enough payload and enough things going wrong with your dependencies or the network, this can go on for a long, long time. But then how do we fix this? And to be honest, when I came up with this theory in our interesting production bug, I was like, well, it's a theory. How do I prove it? Well, probably the only way you can prove this in production is to use TCP dump. And there aren't a great deal of operators who are going to let you log into all of your production boxes and constantly run TCP dumps. And if it happens once every 3 days, you could be waiting a long time. So how do we recreate this type of problem or try and prove it in a test environment? So we're going to use some of these technologies. So Vagrant, if you haven't used it, is just an ability to spin up VMs. It's really useful in your continuous integration environment and spinning up things on your local server. There's a reason we're going to use Vagrant, and that's because we're going to do some interesting things with the network on the box. And no self-respecting ops person is going to let you run things like IP tables and TC on your CI servers, nor should you want to. You could very easily just cut off all traffic to port 22, and then, yeah, you've got a very interesting call to make to your ops guy to go and actually go physically to the box. We're going to use Saboteur. Now, you don't have to use Saboteur. You just have to understand what it's doing under the covers so you can recreate these scenarios yourself. The most important command is TC. IP tables will allow you to block off entire traffic, but that wouldn't recreate that previous example because we wouldn't receive anything in the 500 milliseconds, and we'd hit the socket read timeout. What TC allows you to do is to delay individual packets by a certain amount, or even at a certain probability. So you can say, each packet, I want to delay you by 450 milliseconds. And you can certainly see how we're going to recreate these deterministically in a test environment. Wiremock we're going to use to be the dependency. I really don't care what you use for your acceptance test. You could use something like Cucumber or JBehave. You could write them in Bash if you want, or Perl. It's just something which is going to trigger our service and verify that we've timed out correctly. So if we do a slightly more detailed diagram of what our test is going to look like. So what have we got? This is the Vagrant VM. And we can spin these up on locally or on our CI server. This is Wiremock, and we can prime Wiremock to respond and to actually pretend to be our user service, our device service, etc. We've got our movie, it should be movie service, in the middle. This guy is deployed exactly like he is in production, a nice executable jar with an embedded Jetty or Tomcat or something. And then we've got our acceptance test. What it's going to do is it's going to prime Saboteur to delay traffic. We're then going to interact with our movie service, and we're going to make sure it times out. And if the only thing we've done is set things like socket and connection and read timeouts and resource acquisition timeouts, we can get this to deterministically fail. What you need is a big enough payload to come back, and you want to set your MTU, the maximum traffic unit, to be quite small, just to force it into multiple packets. So that's how you can recreate the issue. And you can play around with this. I mean, you can do things with TC like probabilistically delay traffic, etc. But what I really want are really deterministic tests that run really quickly in my CI server that recreate these scenarios. And this is a real pain to set up the first time. I have a Vagrant VM on GitHub with all of this stuff on, and I've got the code for this guy. It's a really, really simple service you can go and play with. But once you've done it for one of your integrations between your services, between you and a HTTP service or you and a database, and yeah, we could stick our database on this server as well and do the same thing. I had an interesting bug when I used to work a lot with MQ series, which is just a piece of queuing software. And the whole company used it. It was a financial organization. And it turns out that the firewall just dropped all of the connections between our applications and the MQ series. We weren't notified. And then we waited for the default timeouts, which I think are around 5 minutes. So the whole company grinded to a halt. If we start to build tests like this, then we can know that our interaction when we go over the network is going to work. And once you've done it for one, it's really easy to replicate when you're integrating with other HTTP services and other databases. It's a little bit of upfront work, but then you get a lot of gain. So how do we fix it? Well, the root cause of the problem is that we, as an application developer, are giving our precious threads to libraries, etc., that we don't trust. Now, I'm assuming here that we're using a container, and it's the type of container like Tomcat or JBoss or anything, which essentially gives you a thread per connection and per request. So your goal as an application developer, whether you're using servlets directly, not sure why you'd be doing that, or you're using Spring MVC, or you're using JAX-RS or Jersey, or whatever, is you get a thread coming into your method, you need to do some funky stuff that hopefully earns your business some money, and then you need to respond on that same thread. Now, there are async HTTP servers and things, but we're not going to talk about those today. So what you can't do is give it to someone you don't trust. By it, I mean the thread. So the last thing you ever want to do if you want to do deterministic timing out, etc., is give it to a library which you don't have the source code for, or you give it to the network layer, or you want to give it to a database driver. All of these things means that those guys, if they want, can just do thread.sleep for 10 seconds. That's a good way of thinking about it. So yeah, the whole solution is to protect your wonderful container thread that you need to respond on. Now, if you're in the Hystrix talk yesterday, he actually was a really cool example because before introducing something like Hystrix, he showed you, hey, you can do this with an executor. But that's fraught with lots of complications, and you might as well take advantage of the fact that other people have really thought about this, and other people about tuning and monitoring, etc. So in general, like we at Sky, we used a lot of Hystrix. We use Hystrix directly. I'm going to show you some code examples, both from raw Hystrix and from Spring Cloud Netflix. Now, we didn't use this in production yet, so this is a bit of a disclaimer. We just use the raw APIs. Now, this is a library which is basically just for solving this problem. It implements a number of the patterns in the book, the Release It book I spoke about at the start of the talk. So let's see some code. I'll show you the Spring Cloud Netflix one first, just because it's really, really simple. So imagine this. This is a Spring MVC RestController, and it's really simple. On the URL scary, we're logging something out. This is using, I think the example on GitHub is using logback SLF4J. And it's basically saying, resource layer, I wonder which thread I'm on. And by default, it'll be logging out the thread it's on. And we have a scary dependency, right? So in reality, this is just another class. But in your systems and in the real systems, it's going to be, say, calling into a database driver, HTTP client, whatever. And we've got a scary dependency. This is a really good way of thinking about any code that you're calling into that isn't yours. All right? Just assume it's doing this. And what it's doing is it's checking if the current time is even. If so, it returns you a nice scary string. Otherwise, it's going to go to sleep. And that's pretty much what any library could do. Or if they interact with the network or any I/O, that's probably what it will do at some point. And again, we're logging out just to see which thread we're on. And if we look at it, it's nothing surprising here. This guy in the angle bracket, the square bracket, sorry, is the Tomcat thread. So this is a Spring Boot application with an embedded Tomcat. And it's just saying, hey, HTTP 8080, fair enough. But no surprise here, when we call into the scary dependency, we're still on Tomcat's thread. And that's the one that we need to protect and not give away to things like the scary dependency that might decide to go to sleep for 5 seconds. So in general, I'm not a big container fan and Spring fan, etc. They have a real habit of sticking their own annotations, etc., rather than using the industry standards. But I love their integration with Hystrix. It is a really good integration. Good work. What you can essentially do is, with all Spring things, add some magic to your class path, whether you like that or not, I don't mind. And then you can just annotate things which you deem to be scary, or you deem to not want your precious container thread to get into. And here, it's just a simple annotation. There are huge amounts of configuration for Hystrix. I'll go through some later, which you can either put in here or you can do with a property file. And if we go back to our log, something magic has happened. Like all things Spring and annotation-based, it's just magic. We started off on the container thread in Tomcat, but we ended up on this magic Hystrix scary dependency. That's obviously based off the class name of the scary dependency. Now, what this is essentially doing is you can configure Hystrix to do a timeout. And even if your thread is stuck in the barrels of a library in a thread.sleep, it's going to throw you a Hystrix timeout exception, which means you can respond to your client even if all of the threads which are calling your dependencies are locked up and hidden in the depths of something you don't know about. So that's pretty cool. If you're dealing with async libraries, then you often don't need to resort to this. A lot of HTTP libraries, a lot of database drivers, they don't actually use your thread to call into the dependency, right? Or to call to the database or the HTTP service. What they really do is have their own thread pool, but some of them are really, really rude, and what they do is just block your thread anyway. I don't understand why you would ever want to do that. A lot of libraries, though, a lot of HTTP clients, a lot of database drivers, actually will offer you an async interface. And that's where they give you a nice option not to block your container thread. They're going to give you a future back. Now, this is great, but we're going to talk about unbounded queues in a while. So you need to make sure that your drivers are not using unbounded queues for like your requests piling up. And the Cassandra driver is one which gives you a Guava listenable future, which extends, the good old Java feature. So that's as much as any one man can ever talk about timeouts. All right, so we're gonna move on. That's by far the longest section. And a little take-homes if you turned off or you had a nap, but it's not after lunch, so you shouldn't be napping. It's my fault if you're napping. The takeaway is essentially you cannot implement SLAs with network-level timeouts. You may have never got to the network, and they may just eat your thread up for the rest of time. Don't think this is only going to happen if there are network faults. Your dependencies could just be garbage collecting or slow, etc. So it's not just when the network is misbehaving. So what's next? Well, don't try if you can't succeed. And this is something we as humans do completely intuitively. But it's something we very rarely write software. And if you're going to build this nicely distributed system that makes calls out all over the place, if you know that you're not going to meet, say, your timeout, or you've decided, I need to fail this request because the user's canceled it, don't continue to do things. And we tend to just do that. This picture here is a queue for a UK post office. Now, if you've ever been to the UK and you've been unfortunate enough to go into a post office, you will know that these are the slowest queues in the world. This will never move on. And if you've got a lunch break of half an hour or so, and I see this queue, I am not going to wait in it. I'm going to go and do something else, and then I'm going to skip out of work, not at lunchtime when the queue is shorter. Yeah, we have a real habit of writing software where we stand at the back of the queue for 10 minutes, and then we decide to leave. And this is delaying your clients, this is using up resources. We just need to stop doing it. I don't know where this quote came from again, probably the internet. But if applications get complex, we normally send emails. Right? Maybe not applicable now. We have lovely log aggregation services like Splunk and the Elk stack, but we like to send emails. I think the modern version of this is that we will eventually have lots of queues and thread pools. You might not be able to find the queues and thread pools. They might be hidden from you. There's lots of them in database drivers and HTTP clients and things like that. If using frameworks like Akka, they just do the queuing and the thread pool for you. And you really need to understand how these work. And I don't know if I blame Java for this, but every single thread pool and queue you see in Java, Java's abstraction for that is an executor. Right? You submit things to an executor. It might get executed right away by a thread. It might get stuck in a queue for a while and then get executed by a thread. Now, virtually every executor I see in any Java code is using one of the factory methods. You have this cool class called executors. You have a bunch of static methods on it, which will produce you some nicely configured ones, because there are a lot of configuration options on an executor. But nearly all of them give you an unbounded queue, which might make sense in some use cases, but anything where you're trying to build a system which fails fast or doesn't fall over in a big heap, unbounded queues are your absolute enemy. Why? Now imagine you had an unbounded queue for requests going to the user service, and we suddenly get a spike in load. Lots of people decide because there's a new Game of Thrones instance coming out, because everyone loves Game of Thrones. What that queue would do is, of course, we might only be able to make 5 concurrent requests to the user service. That queue would just get bigger and bigger and bigger and bigger. All of our clients would just be waiting. They'd probably have gone to Netflix or Amazon Prime, whatever that's called by now. And in the meantime, we're not going to get some nice diagnostic information. We're going to get an out-of-memory error when the queue fills up and fills up our entire heap, and our application falls over. That's not good for anyone. That's not good for the client. It's not good for you, because it's much harder to debug when those type of things happen. And this is the big point here. Look for them. I love to use open source drivers and HTTP clients, and the first thing I do now when I use one is just do a little search and go and look for these type of things, or look at their configuration. And if they use queues and thread pools and they don't offer you configuration for bounding it and sizing these things, just use a different library, just move on. And it's really quite easy to test as well. Once you've found out that I'm using a library which uses a queue and hopefully it's configurable, if it's not configurable, use a different one. Now, I had to convince some people that we should test this as a quick automated acceptance test as part of our build. People wanted to test this type of thing in our load test environment, which of course you should, but you can really make this a functional requirement, a really easily testable requirement, much sooner than that. And let's say it's your favorite HTTP client, and it's got a thread pool and a queue. You found them. They were hiding somewhere, but you got there. You can probably configure these guys to be one each. One thread, the queue size of 1. What you can do then is you can use a tool like Wiremock, which allows you to inject delays to set a really big delay. Let's just call it 10 minutes. Then you make a couple of requests in your test. Now, the couple of requests are going to use up that one thread and the one piece of space in the queue. Then what happens when you send the third request? Well, if you've got a bug, it's going to hang. It's just going to wait there for a long time. It's going to wait there for 10 minutes. If you've implemented it correctly, then it's going to fail. And you should get a response back within, say, a few milliseconds. So finding these areas, these unbounded queues in our drivers and libraries, and eliminating them or configuring them to be bounded queues is something you can test. Because it's really important, because you might decide to move HTTP client, and you might not understand the configuration there. What you're going to do is instantly have a test that fails. Maybe they changed the configuration of their executor between versions. They stopped using that configuration option, right? Suddenly, your test fails. It's a bad state to get into, to trust that when you upgrade, say, even minor versions of like open source libraries, that they won't change this type of behavior. I really like being able to recreate these in test environments. So the next is fail gracefully, and it's not really, we all build software which fails gracefully. We're talking about other people's software. We're going to expect them not to fail gracefully. I'm guessing that there are some people in the room that are not working on a web page with HTML, but they're in fact working on something which produces JSON or XML, a REST API. We love building those things, right? How many people here have been integrating with a REST API, like our user service to get information about users, and then at some point, it sends you back a stack trace in HTML. I've seen this so many times. And this is the simplest example. And we obviously shouldn't do this, but more importantly, we should expect everyone else to do it. Even if we trust them, even if they're sitting on the other side of the building and we like them, we're going to expect them to do this. And you often get this when you're using, say, Spring Boot, and you move between servlet containers. So you move from embedded Tomcat to embedded Jetty, and they've changed their behavior, and they've decided that if it's a 415, they're going to give you some HTML, because they don't want to give you any JSON. There are more interesting things than HTML coming back to your service that you should test, and you can test. So my favorite is invalid HTTP. If you want to find bugs in your HTTP library that you're using, or certainly to find out that it doesn't fail gracefully, just start sending invalid HTTP to it and see what happens. Malformed response bodies, by that I mean that, yeah, you're expecting JSON, maybe it wasn't valid JSON, or maybe it didn't contain certain fields that you wanted. Okay, unless you've got the data from your external service in memory, you have to expect that it will throw exceptions continually, especially if it's doing any type of streaming. And this is a big one. So you can't trust other people to say, let's say they give you a 10-byte response, they have been doing for many, many days, and then suddenly they give you a massive response, say 10 megabytes, and you decide that you were pulling that into a nice string in Java, and then suddenly you're doing 10,000 transactions a second, and you've just got an out-of-memory error. So I always test with unexpected sizes of payloads coming from my dependencies. And this is actually the reason I got into using something like Wiremock. With Wiremock, you can use it as your happy path testing. You can say, when I call /user, return this nice user JSON. But then you can prime it to do things like some HTML, why not? But you can also do more fun things than that. So here's an interesting one. It has both a Java API and, oddly enough, a JSON REST API, so when you're running it in a standalone mode. So what does this say? So it basically says, if I call this path, then I'm going to return a response with a malformed response trunk. You find some interesting things out about your client then. This one's interesting. You can send empty responses, even though you've, say, set the content length to be large. So if you're reading the content length and then reading that many bytes from your HTTP client, something's going to go wrong here. This is my favorite, though. Okay, random data, then close. If you're going to find some interesting faults in the drivers, etc., that you're using, this will get it. And Java, of course, is a statically typed language. But because we don't like checked exceptions, and we don't like objects like optional and try, we decide to turn everything into runtime exceptions. We want to completely circumvent the compiler, so that, which might be great in our code base, because we kind of can see that. But if we're using libraries, etc., between a minor version, they could completely change how they deal with runtime exceptions. They could throw different ones. If you were catching a, I don't know, Jersey client HTTP exception and doing something, there's no guarantee that they'll continue to throw that exception. So that's why I really don't like mocking of at the process level of things like drivers and dependencies. So here, what we'll do is we're probably going to make that happen. And the great thing about these tests, that if when we upgrade our version of the clients, we're going to make sure that the behavior has stayed the same. Or more importantly, we were stuck on a version of Jersey clients, and there was a bug in it, and we moved to just the raw Apache HTTP client. All of these tests are still completely valid. If we'd done anything like mocking a driver, etc., all of those tests would instantly be completely useless. They'd be really brittle. They wouldn't be helping us as a developer, and obviously tests should be helping you. But we could instantly see how a new HTTP client handles all of these failures. As I said, shameless plug, I built this for Cassandra, so you can kind of inject the types of faults which are really hard to create. So the next is, know it's your fault. Now, since I first did this talk around 9 months ago, there's been a lot of talks on monitoring and monitor everything. It's I have a love-hate relationship with this. Because you get these people on stages waving their hands and say, monitor everything. Then they tell you to shove it to a service. And then they tell you to do microservices and have 100 services, all pushing metrics data to one service. Which thing do you think falls over first? Well, it's the metrics service. And it's when your entire system is under heavy load. When do you really need your metrics and logs? Well, when you're under heavy load and there are problems happening. So I'm currently doing a lot of investigation about how to improve this section. I want to look at systems which are vastly more scalable than the one I'm going to talk about today, which is Graphite. And it's all about knowing your faults, knowing if it's your fault. And we develop a lot of software at the moment where if one of our dependencies fail, we fail, but we don't make it abundantly obvious that it wasn't our fault. Now, this isn't about working in an investment bank and people shouting at you, which they like to do, and blaming you. This is just about being able to diagnose problems in production really quickly. And there are lots of tools for this. Coda metrics or drop wizard metrics is by far the most popular, I think, in the Java space. What's really cool, though, is if you take things like Jersey client or Apache HTTP client, there are instrumented versions of those with drop wizard metrics, or Hystrix, whichever you want to call it. And this means that you can instantly start recording metrics about connection pool sizes. You can instantly start recording. If you're using Hystrix and you want to see how many Hystrix failures there are, you can start using drop wizard metrics to push them to an external Graphite server, which is great. You get to see interesting things. It's a good point to note that this is a good time that all of these things like connection pool statistics, it very much makes it obvious to you that you should have separate connection pools, separate resource pools per dependency. Because if the user service has a problem, we don't want to stop it being able to call pin services, because all requests might not need that. One service I'm investigating at the moment is actually Zipkin. Now, if you haven't come across Zipkin, it was built by Twitter, and it takes a different approach to this. Most people, they put request identifiers in their logs, and then when you make a call, say from the user service to another service, you pass that in, say, a HTTP header, so you can see the whole thing through. Now, Zipkin has a very different approach. What it does is you actually augment your existing services, and there's plugins for other things like load balancers, and it pushes information out to a service, which then allows you to track a request all the way through. So it's quite different from just logging out and doing it that way. This is where the processor actively pushing it to a service, and it has a nice UI where you can track a request. You can see how long does it take in my load balancer, how long does it take in the user service, how long does it take in the pin service, etc. And it's backed by Cassandra, which is, for me, is just a good thing, because I know that all my services are backed by Cassandra, so I know I can scale this thing to the level at which I'm going to push metrics to it. But Graphite is by far the most popular. And so I'm going to talk about Graphite for now. I'm also investigating a different version of Graphite, which rather than uses flat files under the covers, actually uses Cassandra as well. So I just want to use Cassandra for everything. Well, I do when it needs to be scalable. But the great thing about this, if we start to push our metrics out, now you can see here I've got the Hystrix command and I've got the Hystrix thread pool stuff. Org, I think, is going to go into Apache. So my HTTP clients are all pushing metrics to this. Info is my actual package name. These expand out. So what we can start to do is push, say, the 99th percentile to Graphite. And if we're seeing the response time now, the top line is the response time, the 99th percentile of the actual movie service. What the other lines are, these two are exactly the same because this was all on localhost. These two are the response times of the pin service and the device service. So remember the example I was talking about had one service that called out to 3. The red line is the user service. Now, we might be way below our SLA here. This is milliseconds on the left here. Maybe 50 milliseconds is still fine. But instantly, if we start to record this information, we can see where the problem lies. Because if you ever develop the service which sits on the edge, which the actual users actually get to, you just get blamed for everything. They think, it must be the users. And then you have to investigate other services. What you need is a really quick way to identify which is the one which is misbehaving. This is an example of graph of pushing the statistics from HTTP clients. This is Apache HTTP client, and you see we actually have a separate resource pool for the device service, the pin service, the user service. So if all of these guys, all of these connections get stolen and the device service is misbehaving, if we can service some things by just going to the other two services, we're going to be fine because they're separate resource pools. And these things here, this is going to be, that's Apache HTTP. I'm not showing it, but yeah, also these things are wrapped in Hystrix, and you can see those statistics as well. If you're using something like DropWizard, and this is, I don't know how hard this is with Spring Boot, but in DropWizard, it is so easy to push both DropWizard statistics, because they use DropWizard metrics as well, clues in the name, and the Hystrix statistics all out to a Graphite server. Now, if you want to play around with this, but you don't want to learn how to install something like Graphite, I've also got a Vagrant VM on my GitHub, which will spin up a Graphite server on this IP, and the application where all this is kind of running is configured with this configuration, so it will start working. It might use up all of your RAM on your laptop because you're going to have Vagrant VMs everywhere, but at least you don't have to install everything and then work out how to install it and then get rid of it when you're finished playing. Right, we're nearly there. So the last two are very related. We're going to talk about not whacking dead horses, because that's just really mean, and also to turn off broken stuff. So what do I mean by not whacking a dead horse? So imagine this scenario. We've got one of our services misbehaving. The rest of them are fine. Okay, user service is great. Device service is great. The pin service is down. Now, if you built this in a traditional way, you'd probably fail every request. We don't want to let poor little children watching, to watch 18 movies or Game of Thrones, because it's quite disturbing at times. So what do we do here? Well, we have a number of choices. We can fail every request. But what we really want to do is fail quickly and to stop calling something when it's dead. The other thing we could consider doing is disabling pin checks. Now, that's not a decision you as a developer should make if you're building an internet television platform. That's a business decision. But it's our responsibility as technologists to tell people that that is possible. We can have this automatically turn off if you want, and we can default to just success. Pin's good, right? But that's obviously going to have some PR issues if you decide to do that. But is it worse than your entire service going down? One might, you might have to send some apologies. The other means people will probably move to a competitor like Netflix. So, what are we going to do? Well, if someone is not doing so well, they could be your friend, they might not be. Their service could be falling over. There are a number of things we can do, and throttling is another. I'm going to show how to do this with Hystrix, and the one thing which Hystrix doesn't do actually is throttling, but there are other services out there that do that. The best thing to kind of get in your head, though, is this is going to happen. If you put them on the same computer, it will happen every so often. If you put them on different computers with a nice little network in between, it is going to happen. It's going to happen on a pretty regular basis. I'm going to plug the book again, because the book talks about this in quite a lot of detail, talks about the circuit breaker pattern. Now, the circuit breaker pattern is actually quite hard to implement. There's lots of little edge cases. That's why we're going to show you how to do it with Hystrix. But what does it mean? So, closed. you haven't seen this before, this essentially means that our circuit breaker around that dependency is closed. It means that we're going to call it. It's just like your circuit breaker inside your house. Now, you then have some way to say that dependency is not doing so well. In Hystrix, you actually set an error percentage threshold and like a rolling window of how to calculate that threshold. You then go closed. So then you start failing quickly. So if your friends are trying to fix their service over on the other side of the building, you don't hammer them with requests every time they get a new version back up, because that's pretty mean. And eventually, we're going to start sending a request to see whether it's back up. And this is the half-open state. This is, I'm evaluating whether I should begin calling that dependency again. And then at some point, we just go and we're happy and we fixed our production issue. Now, before I kind of showed you a bit of Hystrix with Spring Cloud Netflix, but let's actually have a look at it with the raw API. So here's a nice ugly bit of code. In this time, we're using JAX-RS, because this is a drop wizard application, which is by far my favorite rather than Spring Boot. And we've got a nice endpoint called integrate. What that's going to do is it's going to call 3 dependencies, just like the diagram told you. The user service, the device service, the pin check service. But we've got this extra kind of, boilerplate where we're wrapping them in this dependency, and then we're calling execute. Now, if you're using Spring Cloud Netflix, all it's basically doing is removing this boilerplate. But it's good to understand how it works under the covers. For each of these commands, what you do is you create something which looks a lot like a Java callable, except it's called a Hystrix command with a particular type. And then you stick your dangerous code in here. So our scary dependency from the first example, we'd be putting that code in that run method because we do not trust it. What Hystrix is going to do then is it's going to time it out. We go back to the previous slide. This execute is a blocking call. There's also async options. So if you actually want to you want to use your thread for other useful things, you don't want to waste that thread, you can get a future back from this. Or if you're really hipster, you can get an observable back from this and start doing RxJava. Well, this is great. This is going to mean that we're going to fail quickly. We're going to hit that circuit breaker. But what else can we do? Well, we were talking about changing our behavior to actually allow all of the requests true and just assume that the pin check is successful. And it's really hard. This is something which you probably don't want to try at home. You want to add a method, and you want to add one method, and it's called getFallback. So here, you just basically obviously has to return the same thing, but you can just put a default in here. A common mistake I see when people use things like Hystrix is they then get the fallback from a database. No, that's not a good thing to do, because what you're doing is you don't want to do anything scary in here. You don't want to talk to your database, even if it's your beloved Oracle that you really trust. So don't put anything scary in here. What you actually end up with, if you want to say, common example we had was we called a user service. If that went down, we actually had a cached version in our local database. If you're going to do that in a fallback, you would actually have a Hystrix command in a Hystrix command. And then eventually you'd have a fallback, which would be true or false. Or if you provide no fallback, it's going to fail, which is pretty cool with a small amount of code. So the next thing is, how do you configure this thing? And even if you're going to roll your own, you don't want to use a framework like Hystrix, perhaps you have a requirement like throttling, then you want to go and read its documentation, and you certainly just want to read its configuration, because that will give you an idea of all the things that you need to think about if you're going to roll your own version of this type of pattern. You're going to be able to say, are you going to do it by an error percentage threshold? Are you going to do it by a count? Now, Hystrix has to keep a huge amount of statistics over time to work out when it should do the callback. Now, you can kind of consider that to be a bit of a memory leak, because it's going to store all of these things. So it also just does it over a rolling window and doesn't keep the statistics for very long. So this isn't a replacement for your long-term metric solution. This is very much an operational thing, which is going to keep stats for the last 10 seconds. So that's circuit breaking. But circuit breaking is great, sounds like a fantastic idea, but try to persuade your business that they should turn off bits of your functionality because you're going to build software which is going to fail. They're going to be like, why don't you just build software which doesn't fail? Then you try to explain to them, well, failure is inevitable, there's a network, there's a computer, and they've stopped listening by now because they don't really care. So it's quite hard to get the kind of business buy-in to implement some of this stuff. So the thing we started actually with was turn broken stuff off. Now, you do not need your business permission to put an if statement in your code, right? Hopefully not. So what you can actually do is, rather than use a fancy framework like Hystrix, what you need is some type of dynamic config. It could be Zookeeper, console, it could be JMX if you want to roll that way. and you need to be able to set a property. Cool? So imagine that we've got our movie service, new Game of Thrones episode is released at the weekend, and our system falls over in a big heap. Say the pin service falls down. The manager calls you, because this always happens at a weekend, and says, we really need to fix this. And you just kind of say, should we just turn off pin checking for now and turn it all back on so everyone doesn't move to Netflix? And he's like, yes, please, let's do that. So you click your button, and you turn off, and you just default to true. Just a couple of lines of code right there. Next weekend, the football's on. Manchester United are playing Liverpool, if you've heard of those. And same thing happens. Manager calls you up. But you've got this awesome thing in your contract where you get paid vastly more if you get called at the weekend. So he's starting to get a little bit annoyed. But he says, can you press that button again? You're like, yeah, why not? I'll be the hero again. And yeah, we're done. Third weekend, he doesn't call you up. He says, can you automate this? You're meant to be a technologist. Don't you just make everything happen by magic? And then you're like, well, I can certainly automate that. And that's when you're going to get the buy-in to do things like circuit breaking, right? When you actually have shown that there's an actual need, and there's no way, unless we're superhuman, that we can create software that doesn't fail. I like to think this is the magic button that no one wants to press. Some people don't even know it's there. So to summarize, that's my 6 points. That's my 6 pain points. Hopefully now you're all going to go home and build monoliths. I would recommend it. Or at least just like maybe break it up into a few services. I certainly don't suggest that you have 58 services, each of 100 lines of code, because you're going to really love TCP by the end of that. So these are it. So the most important one, I think, is timeouts. Because the kind of reason you're going to move to distributed computing and horizontally scalable services, you're not the only one doing it. So it's pretty rude if you decide to say, yeah, I'm going to take 200 milliseconds, maybe a second, maybe 5 seconds. You should just fail pretty quickly. If you want to play with some of this stuff and you just want some pre-canned working solutions, here are some links. This is the Spring Cloud one. I did this around 9 months ago, so there's probably a new version. There's always new versions of Spring stuff. The drop wizard Hystrix is the main one. Okay, that's where I'd say no to dependency injection frameworks, and it's raw Hystrix with drop wizard. If you want a Vagrant VM with Saboteur on and a Wiremock jar, then yep, you got that one's there. Also, which I haven't got up here, is a version of Graphite, which you can just do Vagrant up, watch the RAM leave your computer, but at least you then have a running Graphite server with Nginx and a front end. I definitely suggest you go and read this, and Vagrant's really cool. I'm also a part-time Wiremock evangelist. I'm not really. This is a guy in London who develops this, and he does it in his own time. And Saboteur, which is very impressively by the same person as Wiremock. If you don't use it, just go and have a look at the code. It's just a little Python application which calls Linux commands, and obviously you need root access to run those commands, which is why we want to run things on Vagrant. So I'm done there. So I'm happy to take any questions. I realize you're all the way up there, and I can't see you because it's dark over there. Have people been using the mobile app? I can check the mobile app for questions if you want. Technology, hey? Solves everything. The mobile app doesn't work. Shouting works then. Oh no, there's one question. I'll go for it. What solutions do you use for external dependency failures to escalate to IT guys? So yeah, so you're pushing so basically, how do you find out when these type of things happen? How do you escalate it? Now, you can push things to, obviously, Graphite. You can push things to Logstash. You can push things to Splunk, but you need to find out about it. Now, Nagios is by far the most used. Even though you look at the UI and think, was this built 20 years ago? Well, yes, it was. So that's what we used. We actually used a commercial version, but yes, a Nagios. And that can do things like, you can make it connect to things like Logstash, you can make it connect to things like Graphite, or you can write your own scripts to scrape logs, etc., and then email people, because it's a complex piece of software. Any more questions? I can't see.
You are using Hystrix command annotation, where it is configurable somewhere about the circuit breaker stuff. How do you configure it?
How do you configure it? So you can do it at a number of levels. You can do it programmatically. So we're talking about how do we configure Hystrix for all these magical parameters. You can do it programmatically when you're creating those commands. The other thing is Hystrix uses Netflix's dynamic configuration called Archaeus, I think, which you can then either give property files to, and for each of your different commands, you can give a different thread pool size, a different timeout. You can also hook Archaeus up with things like Zookeeper if you just want to store it, if you want a truly dynamic way of configuring it. Any more questions? I'll be here for the next couple of hours, so if you want to question me about any of this stuff, just grab me in the corridor. So thanks very much.